We're going to cover lesson 1.3 in our BJU geometry textbook. And this lesson is about undefined terms and definitions. So our objectives for this lesson is we're just going to identify the characteristics of what make a good definition. We're also going to recognize and visualize some undefined terms of geometry. So we can really only describe them since they're undefined. There's actually no definition for them. We can only give a description of what they are. So let's start with the characteristics of a good definition. There's actually 5 of them. The first characteristic is that your definition needs to be clear. So it needs to communicate the point, and it has to actually state the term being defined. So your definition needs to include the actual term that's being defined. It also needs to avoid vague or ambiguous language. Ambiguous means not specific. The second characteristic of a good definition is useful. So that means that the words that are in the definition, they need to be something that you already know the definition of. They need to be already defined, or they need to be words that we are accepted as undefined, which we are about to go over in a little bit, the 3 undefined terms. The third characteristic of a good definition is precise. So the definition must be accurate and reversible. So it needs to be able to go both ways. Like if you give the definition, you should be able to figure out what the word is that you're defining. And you also need to be able to identify the class to which the object belongs and the distinguishing traits. All right, the next characteristic is concise, and that means that you need to have good grammar, it needs to stick to the point, and it needs to avoid unnecessary words. And the last characteristic of a good definition is objective. So this is all about being neutral, not being biased, no emotional words like love or hate, no figures of speech, and no limitations of time or place. So let's look at an example. Let's look at this definition of space. This definition says space is the set of all points. So to determine if this is a good definition, we just need to look at each of the 5 characteristics in comparison to this definition, space is the set of all points, and make sure that this definition matches every single characteristic of a good definition. So let's look at the first characteristic, which is clear. So because the object being defined is actually named in the definition, so our definition was a sentence that involved the word space, which is what was being defined, that means that it is a clear and good definition. It's also not ambiguous. So now we have useful. So let's look at all the words in the definition. If all of the words have been defined already, then we're okay. Oh, we have a problem because the word set is in our definition. However, the word point hasn't been defined yet. So we have an issue because point hasn't been defined. Set we looked at before in the first 2 sections, but point we have not defined yet. So at this point in our study of geometry, this is actually not a good definition yet because it's not useful. We actually haven't defined the word point. Now let's look at our next characteristic, precise. We're describing space accurately, so that's okay. We classify it as a set, and we describe it. And our definition is also reversible. If we say the set of all points, we know that that's talking about space, so it can go backwards. Concise. The sentence that defines space was very short and simple. It only used what was necessary, and it had proper grammar. So it is concise. And then the last characteristic, objective. All the language was objective and appropriate. There was no bias, so we do have an objective definition as well. So let's talk about undefined terms. So undefined terms are terms that can be described but not defined. In geometry, there are only 3 undefined terms. The first one is point, the second one is line, and the third one is plane. So these are very important. These are like atom blocks. They build up every other definition that we're going to use. These are our starting blocks. These are our building blocks to build all the other definitions. So we're going to want to memorize these. You want to be able to answer the question, what are the 3 undefined terms? And you need to be able to say point, line, and plane. So let's look at each. Point. We can't define point, but we can describe it. So a point is like a spot. It has no dimensions, so it doesn't have length, width, or thickness, and it's just a location in space. For our notation, we always notate a point with a capital letter, and we can mark the location with a dot. So for example, point P. Next we have line. The description of a line is straight. Lines are straight. It extends infinitely in one dimension. So it has length, but it's not going to have any width or thickness. Our notation is going to be 2 capital letters, and those 2 capital letters have to be 2 points on the line. Above those capital letters are going to be a line with 2 arrows on the end. You can also notate a line with a lowercase cursive or script letter. So for example, we can name this line, line M, and see how M is lowercase in cursive. We could also say this is line CD, where C and D are capitalized because they're points on the line, with a line with double arrows. Our next undefined term is plane. Planes are flat, okay? They extend in 2 dimensions. They extend lengthwise and widthwise, but there's no thickness. When we want to notate a plane, we just simply say plane and then a lowercase letter for the name of the plane. So for example, this is plane K, and it's denoted by a lowercase letter. So now I want to talk a little bit about analytic geometry. So we're going to talk about graphing points. Analytic geometry is something that we're going to study throughout the textbook. What it does, it makes a connection between geometry and algebra. So we use algebra in geometry, so it's important to remember your algebra the algebra work that you did last year, because you're going to need it in geometry. So let's review the Cartesian plane. It's also known as the coordinate plane. You have your origin in the middle, and then you have your quadrants. So quadrant 1 is going to start in the upper right-hand corner, and then it goes counterclockwise. So you have quadrant 1, 2, 3, and 4 in Roman numerals. If we want to plot a point, remember our first number is on the x-axis and the second number moves along the y-axis. So the 3 means positive 3 to the right on the x-axis, and then the negative 2 means down 2 on the y-axis. So we plot our point and we go ahead and label it 3, negative 2. Let's go ahead and give the coordinate of each point. If we're looking at A, we had to go to the right 1, 2, 3, 4, 5, and up 2. So A would be 5, 2. B, we had to go left -3 and then up 3, so we get -3, 3. And then C, we didn't have to move left or right, which means X is 0. But we do have to move 2 down, which means our Y is -2. So C would be 0, -2. And this is all for this lesson. Oh, I'm sorry. One more. Let's practice these. Let's practice plotting these points. So -1, 4. The -1 means left 1, and the 4 means up 4. So here's point 1. Point 2 is 2, 2. So to the right 2 and up 2. Notice how we put the dot there, and then we also label it. We can just label it 2 because that was point 2. Point 3 is 0, -2. So 0 means we are not going to move left or right, but we are going to go down 2. Now, point 4 is 3, 2. So we move to the right 3 and down 2. Point 5 is 3/2, 1. So 3/2 is the same as 1.5. So we're going to go right 1.5 and then up 1, and that's 0.5. And all right, and this should be it for this lesson.